This is a topic which is called as a persistence, right? So what is the basic concept behind the persistence is that, a same client will go to the same server, right? Right. So now, why does this this is needed, right? Why the client use the same server at any point of time? Now, this is because if your applications are stateful, right? If your applications are stateful, you can configure big IP system to manage returning user to the same pool member, right? Which is used by previous connections. Understood? When
So
your applications are when you're stateful, you can configure big IP at returning users so that returning users are sent to same pool member, right? Like in this. So like in this, this is a client 1 and this is a client 2. So first packet went to server 1, right? Now this is again, if this will come in a certain point of time, right? It should not be that after 1 hour if it's returning, then it will go to again same server. No, it should be within a fractions of second, 1 or 2 seconds. If it's returning, like you are doing carting and you are selecting the product, that means in a fraction of second you are using the same connections. So on that, the consecutive packets will be sent to same server, and it's if you're a client 2, then it's going on a server 3. Right? For this, you need to configure a persistence based on your client specific data. Right?
Yep.
Now.
Yep.
So there are 2-3 types of persistence, right? So first persistence is called as a source address persistence, right? In the source address persistence, the IP address, right, of the client and its network mask is taken into the consideration, right? When a client sends a packet, first time it is sent to server 1. Now if the same client sends a packet, obviously the F5 has a persistence record. It will see that okay, this is the client, this is the net mask, and it is matching. And if I have a connect any connection established, right, it will see that okay, I have established a connection with a server 1, so let's send it to server 1 only.
Okay.
Right?
Right.
Now the same thing happens.
Right.
For this client only. This client also. Again, it will have a subnet mask of /24. So /24 means this third octet should match, right, in their persistence record.
Right.
Right. So what is the limitation of the source address persistence? There are some limitations in the source address persistence. Not some. There are mostly two. Having some difficulties in that. The first limitation is that if suppose same client returns, right, but using a different IP address, right? Maybe that I am a same client and my IP address is changing, right?
Yes.
In that case, when your IP address changes, right, then your traffic will not be returned to the same pool member. Right? They may not return. I'm not saying they will not. They may return or they may not return. Sometimes it works, sometimes it doesn't work. Right?
Yeah.
And the second issue is that when a client connects using the same IP address via proxy, right? So what happens in the proxy? The proxy makes a session with your client and initiates another session with the load balancer, right? Your destination servers, right? In that case, it leads a situation where a single pool member can receive connections from many clients,
Right.
right? So there are two limitations on that, right? So to with the source address persistence, so there are another another type of persistence is also there, which is called as a cookie persistence, right? One type is source address persistence, which we learned that the returning user will be allowed to send to same pool member, right? And there are two limitations. If the client is changing the address, then it may not be the same pool member, and if the client is coming via proxy, then it may also not come into the same member. The another type of persistence is called as a special cookie. Insert a special cookie with its traffic and send it to the server, right? So let me make you more understand how it works. Let me add some, what happens. Suppose a first hit happens, right? So obviously what happens, as I said that when a client sends a traffic to the big IP, it creates a TCP handshake, right? So first we'll have a TCP handshake,
Yeah.
right?
Yeah.
Done. And then a client will send what it will send. It will send a HTTP request. Suppose I write HTTP request, right? With no cookie, right? Now when this the HTTP request is sent to the big IP, what will big IP will do? Big IP will create another TCP handshake here with the client. Sorry, with the member.
With the member, right?
Right? And then it will send here a same HTTP request, right? With no special cookie. It sends a same packet to member, right? Now member replies, right? So this is a HTTP reply with no special cookie, right? Once the F5 receives the reply, what it will do? It will send a packet to the member with HTTP reply and with special cookie inserted, right? So this is our first hit. So what is this is? This is our first hit, first packet, right? So what happens when a TCP when a first packet is sent from a client to the big IP? Obviously it's a TCP handshake. Now when the HTTP request sent to big IP forwards it as it is, and the member replies it as it is. Once the member replies received by the big IP, what does big IP do? Big IP insert a special cookie, right, on the HTTP reply and sent it to the client, right? So it is a first packet. Now let's after within a fraction of second, the client again requested the same member, right? Same it is a returning user, right? So again, if it is a returning user, there will be a TCP handshake again. Happens, right? Now Once done, the client will send a HTTP request with the same cookie which it has received in the first packet. On the first packet, what? The big API has sent the client with the HTTP reply and it has inserted the cookie, right? On the second packet, the client will send a HTTP request with the same cookie which it has received on a packet first, right? When a big API receives that, right, it again does the handshake.
Yeah.
Right? And it sends a HTTP request with no cookie.
Yeah.
Right? It will receive the packet HTTP reply, right? And now this big API, obviously it has a persistence record, right? For the when it has done for the first packet, it will see that okay, I have the persistence record and I am receiving the cookie from a same client which I have sent, right? It will send a request back, reply back, right, with updated cookie. Okay, with new date and time. You will add date and time and it will so this is your second request, second packet. So this is how, you know, if you configure a cookie persistence, right, and in the insert mode, what happens when a client sends a packet, big API received it, big API forwards it to the member replies it, and once the big API receives the reply from the pool member, it will add a special cookie into it and it sends to the client, right? Here, the big API create a persistence record that the client API address is this one, I have sent this cookie member and my pool member was member 1. Now, when a same client sends a second packet with the same cookie which it has received from the big IP, once the big IP receives the packet, it will see its persistence record. Okay, that this cookie which I have sent, it was earlier sent to pool number 1. So let's send it to pool. So let's send the same traffic to my same pool member. So this is how, you know, insert mode works.
Okay. Okay.
Understood?
Yeah, understood. But couple of questions, please. 1 second. Let me
Yeah.
Can you give me 1 minute? Let me just
Yeah, sure.
take this.
Any information, you know, which the browser sends, right? The client sends on with the help of browser, right? You know, you must have seen that I every time, you know, I deleted the from the internet options. When I go, I delete the, you know, the histories, cookies, like this, right? So it's you know, some characters or some, you know, information which is kept in the you know, browser via client.
Okay. Okay. So, in other words, it's like a cache memory. Can I call that? Is it a kind of caching or mem file of the previous session? The source destination.
You know, request back to the client may be that, you know, big IP will never share the member's IP address, the pool member's IP address, or any information related to the pool, right? Which is because that server may be in your secure zone. Why should we, you know, we disclose the IP information, other things to the client, right? So it's you know, I don't know what's, you know, the big IP actually sends to the client in the cookies, because we don't have, you know, till now I have not, you know, opened the packet of the cookies via Wireshark or something like that, so that I can able to see. But yes, there are some information which big IP sends it to track, right? To track that when I get the second packet with the same, you know, cookie, where I should send the packet to the member. It should send to the packet member, sorry, pool member 1, because the first package was sent to pool member 1. It is just a a marking, right? That if this guy will come, I have sent a packet. If this packet to the pool member one, so if the second packet if I receive with the same marking, I will send this same packet to the my pool member one.
Mhm. Got it. That's okay, Matt. Let's go on to the rewrite. Now, rewrite mode. Next step.
Yeah. Now the second is rewrite mode, right? So
Yep.
again, I will draw the same diagram
Please. That's a good idea.
because it's nowhere
I
in the
like
book.
actually.
You will not found anywhere.
Fantastic.
So when
Thank
I
you.
got
Look,
the
I think that's easy. Good example. Good explanation as well. So that
yeah
I can understand the concept very quickly.
yeah okay
You're right. In the books, they won't explain you so nicely. Even if they're
yeah
nicely, they're
HTTP request will be sent with no cookie, right? Now when a BIP receives the packet, it will send a TCP handshake, right? And
yeah,
the same request is forwarded to the member. Suppose member number one, I'm doing a member number one here with
yeah,
HTTP request with no cookie,
yeah,
right? Now
yeah.
when the member will reply, right, it will reply HTTP reply with blank cookie. It will reply with a blank cookie, right? And once the big IP receives it, it will send, right? Okay, right? So it will send a same HTTP reply, right? Sorry, reply, and with rewritten cookie. Earlier, the earlier in the first part, the when the HTTP reply was sent by member to the big IP, there was no cookie, any cookie inserted, right? But it will insert the member will insert a cookie, but it doesn't have any information. It will have only one field, right, with with no information. And on that blank cookie, when a big IP receives it, it will rewrite some information, and it sends to the client. So this is mostly used in a web server, environment, where web server creates a blank cookie and LTM writes a special cookie while replying to the client. So this is, packet number one, right? Now for the packet number two, again, the TCP handshake occurs and the HTTP request will come. And in the HTTP request, the second packet will have the same cookie which it has received on the first packet. This TCP request comes here, right? Now the big IP sends the HTTP request with same cookie which it has received from the client, right? And the member will reply HTTP reply with blank cookie, right? And then this big IP will send a packet with HTTP reply with updated cookie.
Okay, two questions, Alok, real quick. Why
That
would
means that
yeah, sorry, go
that
on.
yeah. That means, what do you mean by blank cookie? Blank cookie means when a member will reply, it will put a cookie header, nothing else, no information on that. It simply insert a header, cookie header in its reply, and it sends to the big IP. And on the big IP, it will rewrite the because it will rewrite the header, and it sends to the client. Now come your question.
Why would the two questions there? First one is, okay, the packet number one, TCP handshake passed on, HTTP request, the first packet, no cookie.
At every packet.
Yeah, right. I thought within a TCP globalization, so what I thought was once the client and server agree on the window size, that's what, what you call windowing rather.
Yep, yep.
Once the TCP window size is negotiated, ACK, SYNAC, and SYN, SYNAC, and ACK. Once these three handshakes happen initially between the client and server, and the window size is agreed upon, then they don't need to do the handshake on every single packet because they already agreed on, right?
Yes, you are right. You are right. But when you are doing a normal, data transactions, right? But because there is a space between your client and server, and it is a big IP, there is a box, there is a wall between them, and by default it's all deny. So that means for any packet to come in, it will initiate the session.